How is China adapting cutting-edge hypersonic technology to revolutionize air travel? Could this be the breakthrough that brings supersonic passenger jets back into the skies? China's latest innovation, the Quantianhu UAV, a hypersonic drone capable of reaching Mach 4.2, might hold the answer. The quest for hypersonic travel began decades ago during the Cold War. Back then, the focus was primarily military, reconnaissance missions, missile delivery, and dominance in aerospace technology. Projects like the X-15 rocket plane in the US and Soviet hypersonic prototypes demonstrated astonishing speed capabilities but faced technical limitations, particularly with materials, heat management, and engine efficiency. In the civilian domain, the Concorde and the Soviet Tu-144 promised to redefine passenger aviation in the 1970s by offering supersonic speeds. While they achieved some success, both programs faltered due to high operating costs, environmental concerns like sonic booms, and limited economic viability. Now, decades later, hypersonic and supersonic travel is experiencing a renaissance powered by advancements in computational modeling, new propulsion systems, and heat-resistant materials. The Quantianhu UAV is part of this revival, but with an emphasis on practicality, efficiency, and scalability. At first glance, the Quantianhu may resemble a typical advanced UAV, but its capabilities set it apart. Developed by China's Lincoln Tianxing technology, this unmanned aerial vehicle weighs 1.5 tons, spans 7 meters, and is powered by two advanced detonation engines. These engines are the heart of the innovation. Unlike traditional jet engines, detonation engines utilize supersonic combustion, allowing the UAV to achieve speeds up to Mach 4.2, 4 times the speed of sound, at an altitude of 20 kilometers. Not only does this provide exceptional speed, but it also significantly enhances fuel efficiency. In recent tests, the UAV consumed just 6 kilograms of fuel to cover 50 kilometers, demonstrating a breakthrough in energy efficiency at hypersonic speeds. This efficiency could make hypersonic commercial aviation far more feasible than earlier attempts. The Jindu 400S detonation engine powering the Quantianhu is a significant improvement over earlier designs. With multiple ignition cycles and a lightweight build, it generates 4,000 newtons of thrust while weighing only 100 kilograms, two-thirds lighter than its predecessor. This engine pushes the boundaries of hypersonic propulsion, offering a superior thrust-to-weight ratio. The UAV's design has been refined to reduce drag and improve stability. By eliminating the front canard seen in earlier prototypes, engineers have optimized the angle of attack, allowing for more efficient operation in dynamic pressure ranges. The use of 3D printing and supercomputing simulations has been a game changer for the project. 3D printed components enable faster, more precise iterations, while simulations ensure the UAV can withstand extreme conditions at high speeds. China is not alone in the hypersonic race. The United States, Europe, and Switzerland are all pursuing high-speed aviation with varying approaches. US companies like Hermeus are developing aircraft capable of Mach 5 speeds, focusing on propulsion breakthroughs. European initiatives prioritize sustainable designs, including hydrogen-powered systems, but these lag in speed. With the ability to cover 50 kilometers on only 6 kilograms of fuel, it stands out as one of the most fuel-efficient hypersonic designs currently in development. Over 6 years, it has undergone 88 test flights, complemented by extensive simulations. This centralized approach to research and development has allowed China to make swift progress compared to the more dispersed efforts seen in other regions. Unlike many of its rivals, which prioritize military applications, Quantianhu is strategically positioned as a foundation for future civilian supersonic aircraft. By combining advanced propulsion, efficient design, and a focus on commercial viability, it aims to push boundaries not just in speed, but in accessibility and practicality. But here's the big question: can these advancements overcome the challenges that have held back hypersonic travel for decades, or will it remain a dream just out of reach? What do you think? Share your thoughts in the comments below. Don't forget to like, subscribe, and stay tuned as we explore the technologies shaping our future.